On this slide, we talk about limits. So we first start with an example of a function f of x. I have replaced y-axis with f of x, and the function f of x is nothing but x cube. So we have a graph of fx equals to x cube. Our objective is to find the limit of fx, which is x cube, as x approaches 0 or x tends to 0. So we will show that this limit is 0. Yeah, so limit of x goes to 0, f of x equals to x cube is 0. So first we will approach 0 from the negative side and we will show it as 0. So let us see here. So a point here is x, the first coordinate is x, the second coordinate is fx, and fx is nothing but x cube. And as you see, as you move along this graph, you tend to 0. So we are approaching 0 from the negative side, that is from the numbers less than 0. Similarly, we can talk about approaching 0 from the positive side. And again, the coordinates are x comma fx, where fx is nothing but x cube. So as we approach 0, you can see limit of x approaching 0 from the positive side, that is from numbers greater than 0, f of x is 0. So let us see this more graphically. So notice that as we are approaching 0, you can see that f of x is also approaching 0. So now we will approach 0 from the positive side. So let us see this. So we are approaching 0 from the positive side. So the first coordinate is giving you the x-axis and the second coordinate is giving you x cube. So you can stop any place your video and see the values, how they are changing. So in particular, note that you have 0.1 and 0.0001. So we are approaching 0, as you have just seen in the approach. So since you have been able to get value 0 from approaching from the negative side and from the positive side, these equations 1 and 2 agree, that is both have value 0. Therefore we say, thus the limit x goes to 0, f of x, which is x cube in our case, is 0. So here we are particularly talking about f of x equals to x cube. So we say as x tends to 0, f of x also approaches 0. Again, f of x is nothing but x cube here. In general, you could have any function of fx. It could be x plus 1, x square, or anything. So when you say limit of x to a fx equals to L, what it means is as x tends to a, f of x approaches the value of L. And this L is called the limit of f of x. So in the first case, first example, f of x equals to x cube. So the limit was 0. Now when does the limit exist at the point A? So the condition is limit exists at A. This double arrow means if and only if. If you approach A from the positive side of A, that is from numbers greater than A, or you approach A from the negative side, these two limits should agree and say they are equal to something called L, and this L will be called the limit. So we will now cover an example where this case will be, we'll see that the limit is not reached. Consider this function f of x. It is 1 for x greater than 0. So you can see that in purple line. At x equals to 0, it is 0. And for x less than 0, it is minus 1. So we have already drawn the function, as you can see. So let us see if we have a limit at 0. So again, every point here is x comma fx. Fx is minus 1 here for x less than 0. And similarly for the positive side, you have x comma 1 here. F of x is 1 for x greater than 0. So you see, if you approach from the negative side, so you're approaching 0 from the negative side, that is numbers less than 0, you have f of x is minus 1. If you approach 0 from positive side, you have f of x is plus 1. Yeah, again, only x is varying, f of x is constant. So you can see minus 1 and plus 1 do not agree. Now let us see this by a sliding scale. Again, you see that the first coordinate x is changing, but the second coordinate is fixed at minus 1. So you can see f of x is just minus 1 if you approach 0 from the negative side. And again, if you approach 0 from the positive side, only the x is varying, as you can see, and f of x, which is the second coordinate, is constant at 1. And you can see f of x itself at 0 is 0. So you can immediately see now that the limit does not exist. If you approach 0 from the negative side, you get minus 1. If you approach 0 from the positive side, you get plus 1. Since minus 1 is not equal to plus 1, we say that the limit does not exist at the point 0. So we say this thing does not exist. But limit exists for all other points which are not 0. So at points which are not 0, limit does exist. So let us give an example of this. So for example, if x tends to 1, then f of x, which is the function we have written above, this exists. So let us see. Now again, now we are tending x tends to 1. That means x is greater than 0. So if you are very close to 1 but on the negative side of 1, that is at the numbers less than 1, then f of x is just 1. And similarly, if you approach from the positive side of 1, that is numbers slightly positive than 1, then f of x is also 1. Now these two numbers agree. Thus we can say the limit of x tends to 1, f of x is 1. Now things will be more clear if we see in the graph. Now see, the point 1 is marked in this blue dot, and you have this points x comma f of x here. So the arrow marks now denote that we are approaching 1 from the negative side, that is from the numbers less than 1. So again f of x is fixed. Now we are approaching 1 from the positive side, that is from the numbers slightly greater than 1. Again f of x is fixed at 1. So you can see you're approaching this blue point here, and this blue point is the limit. And at this point again f of x is nothing but 1, as you can clearly see in the graph. So you can say that the limit exists here. Now let us see more interactively. Now you can see from the negative side, as we are approaching 1, you see only the x coordinate is varying, the y coordinate or the fx is constant. Now you approach 1 from the positive side, that is numbers slightly above than 1. So you see only the x coordinate is varying and the y coordinate or the fx is constant at 1. So you can see at the point 1, 1, the limit from negative side and positive side agrees, and thus limit exists.